Hello everyone, welcome back to Math Ends On with Python, and today we are going to see how we can solve the transportation problem model with Python. And we are going to see how we can obtain the optimal solution and total transportation cost. So we recap from the example that we did in the transportation problem lecture, and this example was about the concrete company having 3 plants and the 3 construction sites where it supplies the cement from the plants to those construction sites. So we summarized this information in the table, as you can see, and the question today is to obtain the optimal transportation schedule that will minimize the total transportation cost, and basically we are going to do or to perform that using the Python. So now we also developed a mathematical model from that problem, and this is what we get from the information that we are having. So in order to solve this problem in Python, we are going to make a little adjustment, especially to the constraints. Basically, we are told that the plant supply capacities for plant A is 300, plant 2 is 300, plant 3 is 100. That means wherever this plant A will supply to these construction sites, the total quantities that will be supplied here basically will not exceed the plant capacity supply. Okay, that means the sum of quantities which will be supplied to construction site A, B, and C, that is x1A, x1B, and x1C, should be less than the supply capacity of that plant. The same for plant 2 and plant 3. Also, after making this little adjustment for supply constraints, we have also to make a little adjustment for the demand constraints. We have the demands for each construction sites. Demand for construction site A is 200, B 200, and C is 300. But we have 3 plants which we can supply to construction site to meet this demand. What do we do here? That means the total quantities that will be supplied, we set or we restrict it not to be less than the actual demand of the construction sites. That means quantity x1a plus x2a plus x3a, these quantities supplied to a construction site A from each plant should be greater than the actual demand of the construction site. So here we have the adjusted model, as I explained earlier. So we have these supply constraints and the demand constraint now. After having this mathematical model in this shape, now we are going to take this mathematical model to a Python, and we are going to solve it using the pulpy modeler function. So now let's go to the Python. Okay, we have the codes for the problems. So what I do, I will go through these codes and explain how we coded this problem, and you can take this knowledge and apply to any kind of a transportation problem that you will need to solve. So the first part, you need to import the modeler function, and I'm using the pulpy. So I imported the pulpy, and from the pulpy, I called the key functions that are useful or that are used in my problem. So the LP problem function, LP variable, LP status, LP minimize, because the problem, as you can see, is about minimization, GLPK, and the value function. So after importing the modeler function, then we have to create the data for our linear optimization problem. So the problem is having 3 plants and the 3 destinations, which are the sites. So the 3 plants represent the supply points, and the 3 sites represent the demand point. So we also create this data that we are going to use to generate the index list for decision variables. So after having the number for supply and number of demand, then just use these codes here, fix the m and n depending on the number of supply and the demand that you have. Then from there, go to the index list generation for our decision variables, and then because you have already created this data here, so you have nothing to do here. You just write the codes, as you can see, and after generating the index list, then go to the next step, which is the creation of the model that will contain the data and solve the linear problem that we developed. So I create the problem with the name model as LP, then I give the name of the problem as a transportation LP problem, and also I write the nature of the transportation problem. As you can see, basically the problem is about minimization of transportation cost of the cement to the construction sites. So then after, we create the decision variables, and basically because we have generated the list of these decision variables, so we call from this function, and we label our decision variables as X capital, and this X will be obtained from this from the list of index list we generated here, and we have the lower boundary of our decision variables as 0 and the upper boundary as infinite. So we restrict our decision variables, as you can see in the model, to start or to be greater or equal to 0. Then after that, you have to write the objective of our problem. So the objective function of our problem, as we did in the LP, you write the right-hand side expression of the objective function, and you add it to the model problems, okay, we created. And after that, write the supply constraints and add them to the model or to the problem, and also write the demand constraints. Also remember to add these constraints to the model, and after writing the objective function, supply constraints, and the demand constraint, so solve the model problem, this one, okay, we created here, because everything written here have already been added here. So we are solving the model now, which contains the objective function, the supply constraint, and the demand constraint, using the solver, and specifically I'm going to use the glpk solver for this problem. So after this command, then I start printing out, because after this, that means the problem is already solved. So I need the print out. So these are the print out. First, you need the status of your model, whether the current solution is optimal, or the solution which you obtain is optimal or feasible or not feasible. And then you print out the values of your decision variable and the value of your objective function. So these are the codes on how you can write your own codes following this just a few steps that I explained to you. So if you need to see all the codes, let's zoom out. Okay, here you have all the codes. You can see them. Now after explaining the codes, now let's learn this set of codes and see the output solution of our problem. So just click this button here, and the results will appear here. So you can see the output here. We have the list of decision variables with their respective quantities that we can supply to each of the decision variable. So these are the output of the quantities that we can supply to different allocation or sites from the plants. And lastly, you have the objective function coefficient, which is basically a total transportation cost, or we say the total minimum transportation cost after this allocation. So this is how you can solve transportation problems by modeling it into LP model, and then you take it into Python using PALP modeler function. Thank you, and don't forget to subscribe, comment, like, and share the video.